Hello, everyone. Today I would like to cover a very important topic in statistics, and this is the normal distribution. Now, you might remember from a few lessons back that we've covered discrete and continuous data. And you would model discrete data using a histogram, something that looks like this, and continuous data using a curve, something like that. And you've worked with discrete data. Today, I would like to focus on this continuous data. And this graph actually, so let me draw this a little bit up. All right. So this graph is called a bell curve because it looks kind of like a bell. So this is a bell curve, and what's astounding about the bell curve is that most continuous data would fit into this bell curve. So no matter what kind of continuous data you collect, whether it be height of a mountain, height of a person, or body weight, or any continuous data that you're measuring things, then it's going to fit into this bell curve. Okay, so let's look at some characteristics about this bell curve. So this bell curve is symmetric, meaning that if you cut right in the middle, the left side and the right side are going to be exactly the same. They're going to be mirror images of each other. Okay, and also this is a probability curve. This is a probability curve, meaning that if I calculate the whole area underneath that curve, this whole area, that area is going to equal 1. Okay, this area represents the probability. Right? And right in the middle is where I have the mean. And when remember I used that to represent mean, x bar. We use this to represent mean for samples. When we are generalizing the information to the whole population, we use a fancy m. It's called mu. We use this kind of symbol for the mean. And instead of using let me actually notate that on the side here. So instead of using x bar, we are using mu for general purposes, and for standard deviation, instead of using s, we're using sigma. So these are Greek letters. Oops. So for general population, we're using these symbols. Okay, so I'll be using these symbols in this video. So the mean is right in the middle. And that makes sense. So for example, let's consider the height of the male population. And let's say that the mean was 175 centimeters. Okay, so that means most of the people are going to be 175 centimeters, if that's the mean. And if they're not 175 centimeters, they're going to be something close to 175 centimeters. Okay, so that's why the area around the 175 centimeter mark is fairly large. Okay, so this actually be 175. So let's say you're considering like right there. These people, these might be 174 and 176, okay? There are also lots of people who are 174 and 176. because they're not that far away from the mean. But the further away from the mean you get, so let's say that we have something like 160 here, or like 190 here, there's not that many people who are going to be 160 centimeters and 190 centimeters. Right? So that's why the probability for those are fairly low. So the closer you are to the mean, the higher the probability, and the further away from the mean you are, the lower the probability. Okay, let me rearrange or clean this up. All right, so now let's look at standard deviation. How does standard deviation play a role in here? So let's say that our standard deviation is 3 centimeters. Okay, then usually when you move to the side from the mean, you move by standard deviations. So you move 1 standard deviation, and then 2 standard deviations, etc. So let's move 1 standard deviation. Okay, 1 standard deviation. So that's going to be, because standard deviation is 3 centimeters, that's going to be between 178 and 172 centimeters. Okay, that's within 1 standard deviation. And if you calculate the area between or within 1 standard deviation from the mean, this will be 68% of the population. Okay, so that means 68% of the people are between 172 centimeters and 178 centimeters tall. Okay, now this is assuming that our information here is correct, which I don't think it's going to be 100% accurate. I just came up with these information. But if this is correct, then 68% of the people are going to be between 178 and 172 centimeters. Now, if we actually do get the correct mean and the standard deviation, this is still going to be true. So if you move 1 standard deviation from the mean, you're going to be including 68% of the population. Now if you move 2 standard deviations from the mean, so we're moving in both directions here, so this is going to be 181 centimeter, this is going to be 169 centimeters. So we moved 2 standard deviations from the mean. So now this whole area here is going to include 95% of the population. So 95% of the population are going to be contained within 2 standard deviations from the mean, or they're going to be between 181 and 169 centimeters. Okay, now if we go 3 standard deviations, that's going to be between 184 centimeters and 166 centimeters. Now that is going to include 99.7% of the population. Okay, that's almost everyone. Basically, most people are going to be between 184 centimeters and 166 centimeters. Or in terms of standard deviations, most people are going to be within 3 standard deviations from the mean. And this, again, this information is true for most continuous data. It doesn't have to be with the height of men. It can be height for women. It can be body weight. It can be height of mountains. For any continuous data, it's going to fit within this general distribution. Okay, so this is actually called the 68, 95, 99.7 rule. Okay, so within 1 standard deviation, we were going to include 68% of the population. Within 2 standard deviations, we're including 95% of the population. And within 3 standard deviations, we're including 99.7% of the population. Now, based on this information, we can actually deduce the areas under the curve for some of these intervals. So let me actually draw another curve to the right here, or to the left. Okay, and I have the mean towards the middle. Now, let's say that the mean, we'll use the same mean and the same standard deviation. So mean equals 175, standard deviation equals 3. Now let's try and calculate some probability. So what would the probability be that x is greater than 175? Now if you look at the graph, what you would do when you're trying to find the probability of x being greater than 175, or a person being taller than 175 centimeters, you'll find the area under the curve that is bigger than 175. So it's basically this side, right? This is where 175 is. This side is bigger than 175. So you're calculating this area right here to find that probability. And if you look at the graph, I've told you before that this is symmetric, right? So that would actually equal 50%. That would actually equal 50% of the whole population. And the same thing would be true if we did less than, right? That would, let me use a different color here. If we did less than, then we would calculate this whole area here, and which is also going to be 50. Okay, now if we are to be more specific, for example, if I want to say probability that x is greater than 178. Okay, so we've seen before that 178 is one standard deviation away from the mean. This is where 178 is. 178 is right here. So if we want to find that probability that it's greater than 178, we'll have to find this area right here. Okay, that's the probability of it being greater than 178. Now, how do we find that probability? Well, within one standard deviation, we've said that that includes 68%, right? So this right here, this middle section right here is actually 0.68. That's 68%, 0.68. And if you're considering the halves separately, each of these halves are going to be 34% each. Right, so if we are to calculate the blue area here, we're just subtracting, remember the whole thing here was 50, and we're just subtracting this section here. This section is 34, right? So it's just 50 minus 34. So it's going to be 50 minus 34. Let me actually color code this so that you can see it more clearly. Okay, this part, this green part right here is 34, right? That's half of the 68%. So we're doing 50 minus 34 to get the blue area. Actually, the 50 should be in red. The whole thing is 50. 50 minus 34, and that is going to equal 16. So it doesn't look like that on this graph, but this area is going to be 16%. So that means the probability that x is greater than 178 degrees, or not degrees, 178 centimeters is going to be 16%. 16% or 0.16. Okay, so using this fact, using that within one standard deviation is 68%, within two standard deviations is 95%, within three standard deviations it's 99.7%. You can actually find some areas in between these sections here. And that's how you can also calculate their probabilities.